Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, good morning. How are you today? Today we will learn about matrix, equal matrix and operation matrix by Miss Rara. Without further ado, so let's jump to the what is operation matrix. Operation matrix number 2, which is multiplying up matrix. If matrix A has dimension m by n and B has dimension p by q, then A times B only exists if n equal p and the dimension A, B is m by q. So the diagram in here, so we know that if the matrix A have dimension m by n and then matrix B have dimension p by q. So from here we take a look if the rules if n should be same with the p, so that then you can multiply that matrix but the dimension to be m by q, everyone. So this one, if C M N is element of AB, then CMN is also equal with AM1 times B1N plus, remember, when you times the element of the matrix A and then from the element matrix B, you need to adding to get the result. Okay, everyone? Okay, let's take a look from the AB. Okay, for AB, we use rows of A and the column of B is as follows, which is this one. Okay, so from here, you need to check first thing first, you need to check about the dimension. Okay, from the matrix A, they have just one rows, but they have 3 columns, which is the dimension to be 1 by 3, right? How about the matrix B? The matrix B, they have 3 rows, but they have 1 column, right? So 3 by 1. So from A to B, they have 1 by 3 and 3 by 1. So they have the same 3 by 3. So we can cancel 3 to 3. And then the result will be matrix 1 by 1. So from here, let's take a look deep. If we want to multiply this matrix, you need to times by 1 times with the 1. After that, you need to adding symbol or plus symbol with the 3 times 4 plus 2 times 2, and then you need to calculate them. You will get the result 17. So without further ado, so let's jump to the example. Let A equal 0, 5 minus 6, which is this one have this order 2 by 2, and B equal with minus 2 minus 4, 3, with the order 2 by 2. You need to find A times B. Okay, remember, if the A have order 2 by 2 times with the B order 2 by 2, remember, this one is M, this one is N, this one is P, this one is Q, right? So so N with the N with the P, it should be the same. Yes, this one of course the same. So we can write the new A times B matrix with the result is, yes, 2 by 2. So without further ado, so let's recount about this matrix. Okay, the A is 0, 8, 5 minus 6 times by with the minus 2 minus 4, 8, 3. Okay, everyone. So let me change the color to be the thickness is 1. Okay, remember, the rule of this multiply matrix is the the result will be have the same order is the first. And then the second, you need to times between the rows times with the column, right? Rows, the row is 0 times with -2. Plus, you also adding plus is 8 times 8. And then the rows times with the new columns is 0 times with -4 plus 8 times 3. Okay, and then let me change the color to be blue. Row, oh, where is the blue? So this one is row times to column. Row is 5 times the column -2 plus -6 times 8, and then row times the column. So 5 times -4 plus -6 times by 3. So the result is 0 times is 0. This is 64 is 0 is 24. Okay, so this one is 64 is 24 minus 10 with the -48 minus 58, and then -20 minus 18 minus 30x. So this one is minus 30x with the order 2 by 2. So this is the result of the A times B. I hope you understand, everyone. Let A matrix with the entry 2, 1, -2, 3, 1, 5, which is they have the dimension is 2 by 3, and then matrix B with the entry 1, -1, 5, -2, 0, 6, 3, 2, 4 with the 3 by 3. You need to find A and B then A, and then you make a conclusion after that. Okay, remember, to matrix multiplication, you need first you need to find what the dimension they are. Okay, matrix A have dimension 2 by 3, and then matrix B have dimension 3 by 3, right? So from here, for matrix multiplication, they should have a same value between N with the P. Because N is 3 and then the P is 3, so we can continue to find the matrix AB. What's the matrix AB dimension? Matrix AB dimension is 2 by 3. Okay. Because this one is we can find, so we can continue to the matrix. Matrix A have 2, 1, -2, 3, 1, 5 times by with 1, -1, 5, -2, 0, 6, and then 3, 2, 4. Okay. So this one, it will be have 2 by 3 dimension, right? So now, let me change the color first. Remember, to multiplication this matrix, you need to remember the rules number 2 is you need times by with the row with the column they are. The column in here. So, 2 times 1 plus 1 times -2 plus -2 times 3. -2 times 3. Okay, so this is the first row with the first column. So the name in here is A11, everyone. Now we need to find the first row with the second column. First row with the second column, 2 times -1 plus 1 times 0. 1 times 0 plus -2 times 2. -2 times 2. This one is because they have first row and then the second column. So this name is A12. Okay. And then the first row with the third column. So this one, it will be 2 times 5 plus 1 times 6 plus minus 2 times 4. So this is for the first row with the third column. Okay. So now we will find for the second row. Okay, with the color blue. Second row with the first column. So 3 times 1 plus 1 times minus 2 plus 5 times 3 with the name, the second row with the first column. And then continue 3 times minus 1 with the second column plus 1 times 0 plus 5 times 2. Right? Okay, so this is the name second row with the second column. So the last for the second row with the third column. So 3 times 5 plus 1 times 6 plus 5 times 4. Right? After that, you just need to calculate all of them. For the first row, first column is the result 2 minus 2 minus 8. This one is minus 2 plus 0 minus 4. This one is 10 plus 6 plus 8. This one is 3 minus 2 plus 15. Minus 3 plus 0 plus 10. 15 plus 6 plus 20. So the result is minus 8 minus 6, 24. 3 minus 2, 16. 7 and then 41. So this is the result for matrix A times B with the dimension 2 by 3. Now, we are looking for the second, B times A. Okay? How about 4? If we time B and A. Okay, so for B and A, back to again with the dimension. B have dimension is 3 by 3 times with the dimension of A is 2 by 3, right? 2 by 3. Okay, what's happened? B, A 2 by 3. Remember, for the first, you need to find what their dimension. Dimension M times N, P times Q. And it should be same with the P. Look at the N. N is 3 and the P is 2. So we can say this one is, we cannot conclude them because they are doesn't have same values of and not as with the P. So we can finish it. So we can make a conclusion if AB is not equal with the B times A, everyone. Okay? So remember, if the AB is always not the same value with BA. So thank you for today. I hope you understand what I'm explaining today. So we will be next question. Next example, Property of matrix multiplication. If A, B, C are any three matrices whose product are defined and C element of real number, the following property hold. First, A times open bracket B, C close bracket, it's also equal AB times C is associative property. And then A times B plus C it's also equal with the AB plus AC, and open bracket A plus B close bracket C, it's also same with the AC plus BC is from distributive property. And then the 3, so from the scalar AB, it's also same with the CA times B or A times CB. In the general, AB, it's not equal with the B times A, everyone. Number 5, if A times B, it's equal with the A times C, so then in general, B is not same with the C. And then AB equal 0, so we cannot conclude, so or let's say we cannot get the result. If A is a square matrix and n element natural number, so then A power 0 it's equal with the identity, A power 1 it's equal their self, A power 2 it's equal A times A, until A power n, which is the meaning A times A power n minus 1. So the number 8, A times the identity is also equal with the identity times A. You need to remember the identity is, they have the main diagonal from the top left to the bottom right, it's 1. And then the rest of the entry is 0. So the last, if the identity power n, it's also equal identity everyone. So without further ado, so let's jump to the example. The figure saw the computer network from previous example. Find the metric represent the number of ways the data can be sent from one computer to another through exactly one computer. So from here we can see the figure. If they are using the same figure like the previous example, so from this example we need to product their self of matrix because they want to say one computer to another through exactly one computer. So we can write like this one. So we can write A, B, C, D, to A, to B, to C, to D, right? A to A is 0, it's impossible. A to B, it's 1. A to C, it's 1. A to D is impossible. And then B to A is impossible. Yeah, possible if they are through another computer. Like A to C, but to B after that. B to B, it's impossible. B to C, it's 1. B to D, it's 1. C to A, it's 1. C to B, it's 1. C to C, it's 0. C to D, it's 1. D to A is 0. D to B, it's 1. D to C, it's 0. D to D is 0. So from here, because they are asking about, like I said before, exactly, where is the exactly, through exactly one computer, so we can say this matrix name is X, right? This one is matrix X because they have exactly one computer, so that's the meaning. It's multiply of the matrix X. So we can write to be X times X, everyone. So from here, we just need to calculate them. No, calculate. You need to try to answer this one with the matrix with 0, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0, 1. Okay, let me make this one bigger. Okay, 0, 1, 0, 0. You need to multiply them with the same metric because they're talking about the same computer, through one computer. 0, 1, 1, 0, 0, 0, 1, 1, 1 1 0 1 1 0 0 1 0 0. So from here we need to remember multiply the row with the first column. 0 times 0 0, 1 times 0 0, 1 times 1 1, plus 0 0, so this is 1. And then 0 times the first row with the second column, 0 times 1 0, 1 times 0 0, 1 1 1, 0 1 1. So this one is 1. And then the result you can continue by yourself. The result will be 1 1 2, and then 0 0 1 0 0 2 0 0 0 0 0 1 1 0 2 2 1 0 0 1 1. So this is that the meaning, if we can see from this figure to make sure your answer, in the first row and then the first column of this result have 1, is that the meaning A can send the data itself just 1 times from the computer, yes, of the C. How about this one? So you can try to make sure this. Okay, let me example from like in the first row, and then the fourth column means that computer A can send 2, or this one. Computer A can send from to computer D by 2 ways. The first from the B, and then the second from the computer, and then they connect with the computer D. So this is the matrix with the 4 by 4. I hope you understand what I'm explaining, everyone. Let a matrix with the entry to 0 1 minus 1, this one with the dimension 2 by 2, and then matrix B with the entry 0 1 2 minus 3 with the dimension 2 by 2. You need to find AB, BA, A square, B square, and B power 3. Okay, so we need to find AB because they have the same, because they have the same dimension, so we can write A2 2 times by with the B2 by 2. So this is the same, so this will be a result AB 2 by 2, right? So A is 2, 0, 1 minus 1 times by with the 0, 2. Or 0, 1, 2 minus 3. So the result will be have 2 by 2. So this one, so first row times with the first column, 2 times 0, 0. 0 plus 0 times 2, 0. And then for this, the first row to the second column, 2 times 1 is 2 plus 0 times minus 3, 0. And then 1 times 0 is 0, minus 1 times 2 minus 2, and then for the the second row, second column, 1 times 1 is 1, minus 1 times minus 3 is positive 3. So this one, it have result 0, 2, minus 2, and the 4. This one for AB. So we want to find the B with 2 by 2 times with the A 2 by 2. The result will be BL with the dimension of 2 by 2, right? Because N equal V. So now we can continue to find 0, 1, 2 minus 3 times with the 2, 0, 1 minus 1. Okay, so from here, we can continue to find, let me change the color, to find up row times with the column. 0 times 2 is 0 plus 1 times 1 is 1. And then 0 times the first row with the second column, 0 times 0, 0 plus 1 times minus 1 minus 1. 2 Second row times with the first column. 2 times 2 is 4. Minus 3 times 1 is minus 3. And then the second row times with the second column. 2 times 0, 0. Plus minus 3 times minus 1 is 3. So this result, it will be like 1 minus 1, 1 and 3. So from here, we can see if the AB is not equal with the BA, right? Okay, that's it. So now how to find the A square? Okay, we want to find the A square. A square is the meaning A times A. Okay, we have the A, the entry is 2, 0, 1, minus 1 times their self 2, 0, 1, minus 1. So this result will be row times first column 4 times plus 0. First row with the second column 2 times 0, 0, 0 times minus 1, 0. This one, second row with this first column 1 times 2, 2 plus 1 minus 1 times 1 minus 1. Second row with the second column 1 times 0, 0 minus 1 times minus 1 is plus 1. So this result will be like 4, 0, 1 and 1. Okay, so this is for the A square, right? So you need to find the rest of them for B square and then B3, everyone. Let A with the matrix 0 to 3, 0 with the dimension is 2 by 2. You need to find A power 2006. Okay, before we find the A power 2006, we need to find first about A power 2, everyone. So from here, A times A, it's equal with their self. No, not their self, I mean 3, 0, 0, 2, 3, 0. So we need to multiply them to be first row times with the first column. 0, 0 is the 6. First row with the second column. 0, 0. So this one is 0. Second row and then the first column 3 times 0, 0, 0 plus times 3, 0. This one 3 times 2, 6. Okay, this one D for A square. Now let's jump to the A power 206. A power 206 is that the meaning. Before we continue this one, so I can make this matrix to be what's the name? To be scalar matrix, which is I make the 6 to F from here and then to be 1, 0, 0, 1, which is this one. We know that if this one is identity, so we can write to be 6i, 6 identity of matrix. So from here we continue. So this one make it to have their square. So if they have square, so this one is left 1000 of, yes, 1000 of 3. Because we know that if the A square is 6i, so this one is 6 identity power 1000 of the 3, right? Okay. This one, it will be equal with 6 power 1000 of 3 times with identity power 1000 of 3. Remember of the property, if the E power 1000 of 3 is equal with this, with the I, right? So this one I can write to be 6 power 1000 of 3 times the I. So remember what is identity? Identity is the from the top left to the bottom of the right is 0, 1, 0, 1. Because from the beginning we are using 2 by 2. So for in here we are using 2 by 2 again. So this one will be have the result 6 power 1000 of 3, 0, 0, 6 power 1000 of 3, everyone. I hope you understand what's explaining, but remember, if they have identity power anything, so they will be back to the identity. So the matrix with the entry minus 4x minus x4 with the power 2, it's equal with the minus 1, 0, 0, minus 1. So first thing first, you need to multiply the left hand side. So we will answer left hand side with the power 2. So minus 4x, x is 4. You need to times first between this one. So okay, so this will be have the result will be first row with the first column minus 4 times minus 4 is 16, x times minus x squared minus 4 times x minus 4x plus 4 times x is plus 4x. And then the second row with the first column minus x times minus 4 is 16. Oh, sorry, not 16, but they are 4x. Now 4x, 4x, 4 minus x minus 4x. And then the second row and then the second column, it will be minus x times x minus x squared plus 16, everyone. With this one, it's also equal with the minus 1, 0, 0, minus 1, right? Because we continue to calculate them. So this one is 16 minus x squared. This one is 0, 0, 16 minus x squared. So this one is equal with minus 1, 0, 0, minus 1. So from here, we can see 0 is equal 0 is correct, 0 and 0 is correct. So we can continue to this one to be, we need to find the x because we don't know what they have. Because we don't know what the value of x, I mean. So this one is 16 minus x squared equal minus 1. You can choose what they are, the first column, first row, or the second row with the second column. It's depend on you. So 16 plus 1, it's equal with the x squared. So 17. So this one is square root of the 17. So this is the result for the x equals 17. I hope you understand what I'm explaining today. So everyone, thank you for today. I hope you understand. So please study hard and then do your task. So, Assalamualaikum warahmatullahi wabarakatuh.